Welcome to the next part of maths chapter differentiation. So this part is on exponential and logarithmic functions differentiation. So first, what is exponential function? A function f of x or y is equal to b raised to x is called exponential function with positive base b which is greater than 1. The base must be greater than 1. The domain of exponential function is the set of all real numbers. Domain is the x, value of x. You can put any value of x, any real number. Okay, but range is only the range of exponential function is only the set of all positive real numbers. Okay. Third thing is point 0, comma 1 always lies on the graph of exponential function. Let it be any exponential function. Let you take any value of x and put it in the exponential function. You will always find that point 0, comma 1 always lies on the graph of exponential function. See, for x you are allowed to take any value. So whenever you take value of x as 0, the answer of exponential function is 1, becomes 1. Why? Because anything raised to 0 is 1 for any real number b which is greater than 1. The exponential function is always an increasing function. Increasing function is that if you increase the value of x, your domain, the range also increases. The graph of exponential function approaches x-axis in the second quadrant but never meets it. For large negative values of x, the exponential function is very close to 0. This is how an exponential function looks like. Okay, this is the graph of exponential function. So some common types of exponential function is are number one, common exponential function with base 10 and natural exponential function with base e. If you want to know more about exponential function, you might want to have a look at my basic logarithms video, in which I have in detail explained this. Today's criteria is not to understand exponential function in detail, but to differentiate exponential function. So let's quickly go to the differentiation. Derivatives of exponential function. So now we know that derivative of a raised to x, that is an exponential function, when a is greater than 0, the base is always greater than 0, x can take any real number. Let's derive it. Okay, so first of all we find f of x, which is given to us, a raised to x. Then what will be f of x plus h? Why we need to find f of x plus h? Because if we want to find the formula for the derivative of exponential function, we have to use the first principles. Okay, so what is the formula for first principles? F dash of x, that is derivative of f of x, is f of x plus h minus f of x upon h when limit of this thing when h tends to 0. So f of x plus h is a raised to x plus h. So limit when h tends to 0 of a raised to x plus h minus a raised to x upon h. We can simplify this. We can uh, write a raised to x plus h as a raised to x multiplied by a raised to h minus a raised to x. We can take out a raised to x common. So it becomes a raised to h minus 1 upon h. Okay. So this a raised to x, since it is a constant, it can be taken out of the limit. And here a raised to h minus 1 upon h is a standard formula with which you can solve it. So the limit of a raised to x minus 1 upon x when x tends to 0 is log of a to the base e. So here you will get log of a to the base e, and there is no mention of x in the formula. So the power is not mentioned. Okay, so here the power is h, the denominator is h. It does not matter. You just write a raised to x multiplied by log of a to the base e, and that is the formula for derivative of exponential function. So d by dx of a raised to x is equal to a raised to x multiplied by log of a to the base e. Remember the formula. You have to apply the formula. Okay, Similarly, we can derive the formula for e raised to x. Okay, see, we take f of x as e raised to x, then f of x plus h will be e raised to x plus h. We apply this formula, the first principles formula, and simplify, take out e raised to x common, and e raised limit when h tends to 0 of e raised to h minus 1 upon h is nothing but 1, right? So why 1? Because see, the answer is log of a to the base e. Here you will get log of e to the base e, and log of e to the base e is nothing but 1. So the answer will be e raised to x. So d by dx of e raised to x is nothing but e raised to x. Always remember. See, if you replace a with e in the first formula, okay, you get d by dx of e raised to x as e raised to x multiplied by log of e to the base e, and we know log of e to the base e is 1. So e raised to d by dx of e raised to x is nothing but e raised to x. So that's your second formula. So in exponential functions, for common exponents and for natural exponents, we have two formulae. First is this one, d by dx of a raised to x is equal to a raised to x multiplied by log of a to the base e, and the second one is d by dx of e raised to x, which is nothing but e raised to x. Then comes logarithmic functions, which are inverse functions of exponential functions. Remember, logarithmic functions are inverse functions of exponential functions. Again, I'm telling you, if you have any doubts in logarithmic functions, exponential functions, their graphs, their domains, their range, if you want to know them in detail, I have a separate video in which I have explained exponential and logarithmic functions in detail. Here we are not studying these functions in detail, only we should know that in logarithmic functions, the domain is positive real numbers, which was the range of exponential function, and the range is all real numbers, which was the domain of exponential function. Logarithmic function is always an increasing function. The point 1 comma 0 always lies on the graph of logarithmic function. It is exactly opposite to the point 0 comma 1, which always lies on the graph of exponential function. Okay, the graph of logarithmic functions approaches y-axis but never meets it. Okay, just like the graph of exponential functions approaches x-axis but never meets it. So these are the graph of logarithmic functions. There are two types of logarithmic functions: common logarithms with base 10 and natural logarithms with base e. Okay, natural logarithms are denoted by ln together, or L and subscript n. It's the same thing, natural logs. Okay, so derivative of logarithmic function, that's what we are concerned with over here. See, the derivative here is found with the first principle, so you might want to pay some attention. We know that f of x is equal to, see, the first is common logs. Okay, common logs is with base 10, but here they have taken base a. Let it be base a. We'll find out. F of x is equal to log of x to the base a. Now what we'll do is, we'll find f of x plus h. So wherever there is x, we'll put x plus h. Now the formula for finding derivative of a function is limit when h tends to 0 of f of x plus h minus f of x upon h. So log of x plus h to the base a minus log of x to the base a, the whole upon h. Okay, so limit when h tends to 0 of 1 by h, see, h comes out, so 1 by h multiplied by log of x plus h upon x to the base a. Why? Because we have this formula, log of m minus log of n to the base a is equal to log of m by n to the base a. I hope you know this formula. Okay, so what we do is, we apply okay, what we do over here is, we uh, we divide this x in under the denominator of both these terms. So x by x plus h by x, that is 1 plus h by x. This is what we get to the base a. 1 by h remains over here. Okay, now This is important. This is very, very important. See, what they have done is they have taken out x by h out of the log, x by h out of the log, remember, and they have written 1 by x outside. In first 1 by h was outside, so what they have done, they have multiplied and divided by x. So since they have multiplied and divided by x with the whole term over here, what do we get? We get x by xh. Okay, so x by xh, out of x by xh, remember I will write it like this, x by xh. I will write x by xh as 1 by x multiplied by x by h. So x by h is written over here inside and 1 by x outside. So x by h multiplied by log of a, log of 1 plus h by x to the base a. Okay, and outside the bracket you write 1 by x. So what happens is whenever you multiply something, whenever you multiply something in front of the log, it becomes the power of the number whose log has to be found out. So x by h becomes the power. Okay, so limit of 1 by x multiplied by log of see, now we open the bracket. Okay, so limit of 1 by x multiplied by log of 1 plus h by x raised to x by h to the base a. This is what we get. That number n goes into the power. Don't get confused. This is confusing, I know. Okay, now what next? So we had got this already. ठीक है, यहाँ तक तो हमें आ गया था. Now what? Now just see this. 1 by x multiplied by log of a is kept out, and this limit is given to the inside term. And here we have 1 plus h by x raised to x by h. You remember this formula from limits, limit of 1 plus x raised to 1 by x. If this is x and we have the reciprocal of x as power, when x tends to 0, the answer comes to e. So limit of 1 plus h by x raised to h when h tends to 0 gives you 1 by x multiplied by log of e to the base a, log of e to the base a. Okay, and this is your final answer. So d by dx of log of x to the base a is equal to 1 by x multiplied by log of e to the base a when x is greater than 0. When we have a is equal to e, the answer is just 1 by x, because a will be replaced by e in the answer also, and log of e to the base e is nothing but 1. So when we have d by dx of log of x to the base e, the answer is just 1 by x. So remember that d by dx of log of x to the base e is 1 by x, or d by dx of log x, where it is natural log, we get 1 by x. Okay, there is one more corollary of this, that is d by dx of log of mod of x, which is also equal to 1 by x. Okay, let's see if they have the, no, they have not given the proof. So yeah, the final list of formulae is something like this. D by dx of a raised to x is a raised to x multiplied by log of a to the base e, where a is greater than 0. D by dx of e raised to x is nothing but e raised to x. D by dx of log of x to the base a is 1 by x multiplied by log of e to the base a when x is greater than 0. D by dx of log of x is 1 by x where x is greater than 0.5 they are saying, and the base over here is e. And d by dx of log of mod of x is also 1 by x where x is not equal to 0. Okay, so these are few formulae which we are going to use in the next part, that is based on the differentiation of exponential and logarithmic differentiation. Let's start with the first question. Is it true that x is equal to e raised to log x for all real x? That means, is this equation true for all the real values of x? Now, before you comment on this, remember that in logarithmic functions, the domain can be only of positive real numbers. Here, log of x is the power of e. We are taking log of a number. So this x is nothing but the domain. And this domain x happens to be here as well. Now this domain of log has to be a positive real number. So this equation will not be true unless and until x is a positive real number. So is it true for all real x? How do we do that? So we know that no, the given equation will only be true for all x belonging to positive real set of positive real numbers. All x belonging to set of positive real numbers. Okay, so to prove this, what we will do, let y is equal to log of e raised to log of x. So we take y as e raised to log of x. For simplifying this, we'll take log of both the sides. So taking log of both sides. So what do we get? Log of y is equal to log of e raised to log of x. Now, since we are taking log of y, log of any number, we know that log of any number, if we are taking that number has to be from the set of positive real numbers. Here, y must belong to r plus, correct? Okay, so log of y is equal to, see the power just gets multiplied ahead. So we get log of x multiplied by log of e. So no base is given to you. So you have to consider the base as e. Now log of e to the base e is 1. So we can say that log of y is equal to log of x multiplied by 1. That means log of y is equal to log of x. And that means that is x is equal to y. That is x is equal to y. Do you understand why x is equal to y? X is equal to y because log of x is equal to log of y. That's what we have proved. And what is y? Y is a positive real number. Hence, we can say that x, I'm sorry for that, x also belongs to r plus, to the set of positive real numbers. Okay, so this is the justification. Let's go to the next question. Differentiate the following with respect to x. So we have a exponential function. Okay, so let y is equal to 3 raised to x plus 2. Therefore, dy by dx, differentiating both sides with respect to x, we get. So how to differentiate this? The formula is, let me write it over here so that there is no mistake. D by dx of a raised to x is equal to a raised to x multiplied by log of a to the base e, where a is always greater than 0. This is the formula. Okay, so here the power is x and here the power is x plus 2. So we have to apply chain rule. Now for applying chain rule, we'll first treat this power as the stuff which we cannot touch. So we'll treat this power as x. Okay, so what will it become? this will become a raised to x, that is 3 raised to x plus 2, multiplied by log of a, that is your 3 to the base e, log of 3 to the base e, multiplied by d by dx of chain rule. So that function within a function we have, so that stuff we have to differentiate now, x plus 2. Okay, so dy by dx becomes 3 raised to x plus 2 multiplied by log of 3 to the base e multiplied by d by dx of x plus 2, that is d by dx of x multiplied by d by dx of 2. Okay, so we have log of 3. Okay, so this will be inside bracket. You can put a bracket over here or over here. So this will be d by dx of x, that is 1, and d by dx of 2, which is 0. So the answer is 3 raised to x plus 2 multiplied by log of 3 to the base e. If you don't write to the base 3, it is if you don't write to the base e, it is understood that it is to the base e. Okay, so it is natural log only. All right, let's check the answer. Yes, it is correct. Let's go ahead. If xy is equal to e raised to x minus y, if xy is equal to e raised to x minus y, prove that dy by dx is equal to y bracket x minus 1 upon x bracket y minus 1. Nice question. See, so we have xy is equal to e raised to x minus y. See, what we can do is, if you want to find the value of dy by dx, either you can differentiate this equation as it is, or something is there in my mind where I feel that I should take x to the other side and then differentiate and then see what we get the value of dy by dx as. Okay, so let me try what I want to try. Okay, so I'll take y is equal to e raised to x minus y upon x. Correct? So this will be y is equal to e raised to x divided by e raised to y the whole upon x, and you can write it as y is equal to e raised to x upon x multiplied by e raised to y. Okay, so we have something like this. We can keep it e raised to x minus y also, because that's, I don't think there is a problem. But still, if we want to uh, simplify and write it like this, it should not be a problem. Okay, let's see how to simplify this. Okay, I saved some time here. So I wanted to try the method which was in my mind, which was not matching with the method shown here in the solution. So that's why I thought that I will try first, and if I get the correct answer, then I will discuss with all of you. So what they have done is they have differentiated xy on the left hand side directly, and what I thought was to take x on the other side in the denominator and leave y alone over here and then differentiate. Okay, so just see the simplification and then I'll explain you the differentiation also. It's very simple, but yeah, it is very long because there are many steps. So I've broken down the whole process into small parts and then I've differentiated. Okay, so e raised to x minus y is nothing but e raised to x divided by e raised to y, the whole upon x. And we can take this e raised to y in the denominator, so it becomes y is equal to e raised to x the whole upon x multiplied by e raised to y. Now I have differentiated both the side with respect to x. So y becomes dy by dx, and here we get d by dx of e raised to x upon x multiplied by e raised to y. Then I have used the quotient rule, which I have written over here. You all must remember what is quotient rule. So on application of quotient rule, what I get is uh, denominator multiplied by the differentiation of numerator minus numerator multiplied by the differentiation of denominator, the whole upon square of the denominator, right? Okay. After this, please pay attention. After this, I'm going over here. Uh, d by dx of e raised to x is e raised to x. So I just kept it e raised to x. So here I got x multiplied by e raised to y into e raised to x minus, here in this term I had to first apply the product rule. Okay, d by dx of x multiplied by e raised to y. So product rule says, okay, e raised to x remains as it is, and inside the product rule says first function multiplied by the differentiation of second function plus second function multiplied by the differentiation of first function. So d by dx of x is 1, and upon x multiplied by e raised to y the whole square becomes x square multiplied by e raised to 2y. In the next step, this thing remains as it is. Here d by dx of e raised to y is e raised to y, but since this is an implicit function, I have to also write dy by dx with that, and e raised to y multiplied by 1 is e raised to y. Okay, this much is clear to you. Next, in the next step, what I do is I take e raised to y outside. Both the terms have got e raised to y, I keep it outside. E raised to x is already outside. Inside I'll be left with x dy by dx plus 1. In the next step, I take out e raised to y and e raised to x common from both the terms. So inside I'll be left with x minus x dy by dx, there is a minus sign over here, and minus plus minus 1. And upon this x square multiplied by e raised to 2y becomes e raised to y into e raised to y. One of the e raised to y gets cut over here, and the denominator remains as it is. After that, I hope you're understanding, because I've solved the whole thing stepwise properly. I've not skipped any step, and I'm directly showing it to you what I have done. If I would have written it and then showed it to you, it would have taken a long time. That's why I solved it first. I wanted to check whether what I'm thinking is correct or not. So that's why I have already written it. Okay. E raised to x upon e raised to y. See, e raised to y was there already. So e raised to x upon e raised to y I wrote together. 1 upon x square I wrote together, and in the bracket I wrote x. I took out x common from both these terms, so x bracket 1 minus dy by dx and minus 1. Then e raised to x upon e raised to y is e raised to x minus y, and according to the question, e raised to x minus y is nothing but xy. So I substituted the value, because whatever I had to prove, I did not have e in that. Right, so I had to get rid of that e. So e raised to x minus y in this step will give me xy here in the numerator. In the denominator, I've got x square. So x square is x, and this xy is x will cut, and I'll be left with y by x. Now this y by x I multiplied inside the bracket, y by x multiplied by x and the whole bracket all together here, and y by x multiplied with minus 1. So I get minus y by x. Here x cancels, I cancels, and I just get y. Y I multiply it inside, so y minus y dy by dx minus y by x. I took y dy by dx to the other side. Y minus y by x is left over here. And when I take LCM, it becomes xy minus y upon x. On the other side, if I take out dy by dx common, I am left with 1 plus y. I take this 1 plus y in the denominator over here. So I get the value of dy by dx, which was required. I hope you understood. This was a little long question, but not difficult. Okay, only thing that you need to have little patience, because if you see the solution, it does not match with my method at many instances. Okay, although they are getting their answer easily. So I could have easily shown you this same method, but I want you to understand that whichever method you use, even though it is little bit longer at first, then by and by you start understanding that how to make your method smaller. Okay, but that does not happen overnight. So you need to start with a method which you understand. So I'm doing a method which I think you will understand. Might be little longer, but doesn't matter. We are getting the correct answer, and our method is legitimate. Okay, next question. Differentiate. Now this is inverse trigonometric function. Okay, so be careful. Differentiate sine inverse of bracket 2 raised to x plus 1 the whole upon 1 plus 4 raised to x with respect to x. Okay, now in this question, if you look closely, there is a pattern which you will be able to see. The pattern is there is a formula of sine 2 theta, which I want you to see here. If your trigonometric formulae are good, if you remember all the formulae, then you must remember this formula. Sine 2 theta is equal to, I will show you where you can see this formula. Sine 2 theta is equal to 2 tan theta, 2 tan theta upon 1 plus tan square theta. If you see this formula, you will know that where to substitute what. Now this whole thing which I highlighted, that is sine inverse of that that bracket, that bracket could be converted in terms of sine 2 theta. But to convert that bracket in terms of sine 2 theta, first I need to bring the ingredients which are there inside in terms of tan theta. For doing that, I need to substitute something as tan theta. What as tan theta, I don't know, but something. Okay, so that I can use this formula, and this format and the question, the format given in the question in the bracket looks very much similar. So this is how you figure out कि क्या substitute करना है. इसके लिए फॉर्मूला तुरंत माइंड में आना चाहिए. अगर नहीं आ रहा है तो फॉर्मूला लर्न करो ट्रिग्नोमेट्री के, तो ये सब्सटीट्यूशन कहाँ कौन सा कैसे करना वो समझ में आएगा. अब यहाँ पे the substitution method which we learned in the last part, that is also used. And since there is power exponents, we are also dealing with derivatives of exponential functions. तो दोनों चीज हो रही है. ठीक है, कैसे इसको सिंप्लीफाई करेंगे, लेट्स सी. सबसे पहले see how to write this thing. So let y is equal to sine inverse of 2 raised to x plus 1 the whole upon 1 plus 4 raised to x. Okay, now can I write it as y is equal to sine inverse of 2 raised to x multiplied by 2 raised to 1 the whole upon 1 plus 2 raised to x the whole 1 plus 2 raised to x we have, right? The whole square. The whole square means 2 raised to x multiplied by 2 raised to x, right? And what do we get 2 raised to x multiplied by 2 raised to x? Actually, it should be 2 raised to 2x. We have 4 raised to x. 2 raised to 2 raised to x. Okay, it can be also written like this, yeah. 2 raised to x the whole square. See, I think 2 raised to x the whole square can also be written, right, like 2 raised to 2 the whole raised to x. That is 4 raised to x. Absolutely correct. Okay, so 2 raised to x the whole square in the place of 4 raised to x is absolutely correct. And why are we bringing this? Why are we changing this format? I will tell you why. Do you see that there is a 2 raised to x over here? And do you see that is the 2 raised to x over here itself? Okay, so can we write it like this? Y is equal to sine inverse of 2 into 2 raised to x upon 1 plus 2 raised to x the whole square. Yeah, nothing wrong in this. And if you see this format, this formula, this statement which I have written, it is very much similar to the statement I have given you over here. In the place of tan theta, I have 2 raised to x. In the place of tan square theta, I have 2 raised to x the whole square. So tell me, what should we substitute? What should we substitute? So let put 2 raised to x is equal to tan theta. 2 raised to x is equal to tan theta. So theta will become tan inverse of 2 raised to x. Tan inverse of 2 raised to x. Okay. Now we will use that later. We will use that later. Don't worry about that. But first do the substitution. Now that you have seen that pattern, do the substitution. So y is equal to sine inverse of 2 multiplied by tan theta the whole upon 1 plus tan square theta. 1 plus tan square theta. Okay, so what is 2 tan theta upon 1 plus tan square theta? It is sine 2 theta. So can I write it as sine inverse of sine 2 theta? Yes, definitely. And can I write it as y is equal to 2 theta? What is theta? We have to put the value of theta, right? What is theta? Theta is equal to tan 2 tan inverse of 2 raised to x. 2 tan inverse of 2 raised to x. Okay, now let us find dy by dx. So dy by dx is equal to d by dx of 2 multiplied by tan inverse of 2 raised to x. Okay, 2 will come outside. Okay, d by dx of tan inverse of 2 raised to x. Now this is a function within a function. So basically we have to use chain rule. First, let us understand what is the differentiation of tan inverse of 2 raised to x, considering this as the stuff which we do not touch, multiplied by d by dx of 2 raised to x, right? So that's the whole chain rule which we are going to find. So we have dy by dx is equal to 2 multiplied by d by dx of tan inverse of 2 raised to x. See, tan inverse of x, the differentiation of that is 1 upon 1 plus x square. 1 upon 1 plus x square. So we have 2 already. We are just going to write 1 upon 1 plus, in the place of x I'll write 2 raised to x the whole square. Now 2 raised to x the whole square, let me just write it as it is. It is actually 4 raised to x. Okay, multiplied by, what is the differentiation of 2 raised to x? This is in the form of a raised to x. So its differentiation is a raised to x, that is 2 raised to x, multiplied by log of a to the base e. Log of a is 2 to the base e. That's it. Okay, so we have 2 multiplied by 1 upon 1 plus 4 raised to x multiplied by 2 raised to x multiplied by log of 2 to the base e. You can bring them together. If you want, you can bring the whole thing together and simplify. Like here we have 2 and 2 raised to x in multiplication. So you can write it as 2 raised to x plus 1 multiplied by log of 2 to the base e, the whole upon 1 plus 4 raised to x. Okay. If you don't write to the base e, that is also fine, because here it is understood that this formula is only for natural logs. Correct? So this is the whole solution, differentiation. Okay, the answer is correct. Okay, the method is also correct. So this was actually the first use of substitution which we discussed in the last part, and there was no formula, visible formula question where we could apply that substitution. Anyways, no problem. Okay, one more similar question like that. Again, we have sine inverse of something which looks quite promising and in the form of the same formula. So here in this question, I'm going to give you some hints, and I'm going to simplify and bring this bracket in the form of sine 2 theta. What is sine 2 theta? Sine 2 theta is equal to 2 tan theta the whole upon 1 plus tan square theta. So if we can do that, see, because it is very much similar to what I'm showing you here. If we can do that, if we can substitute something and do that, we can achieve it. But what to substitute and how to substitute? So I'm not going to write the whole thing here. I'm just going to focus on this highlighted part, the bracket. If we can bring it in this form, then ahead you know how to do it. You can deal with the whole question. Differentiation is also not a problem. The problem is substitution here. Okay, so 2 raised to x plus 1 multiplied by 3 raised to x the whole upon 1 plus 36 raised to x. This can be simplified as 2 raised to x multiplied by 2 raised to 1 multiplied by 3 raised to x the whole upon 1 plus 6 square raised to x. Okay, so this will become 2 multiplied by 2 raised to x into 3 raised to x is 2 into 3 the whole raised to x. The whole upon 1 plus 6 raised to 2x, or 6x raised to 2, or 6 raised to 2x. Nothing, no difference in that. Okay, so here we can write it as 2 multiplied by 6 raised to x upon 1 plus 6 raised to x the whole raised to 2. So tell me now what you will substitute in place of what? Yes, in place of 6 raised to x, you are going to substitute tan theta. That makes theta equals to tan inverse of 6 raised to x, which will be useful for resubstitution later. So I want you to pause this video. I'm not going to solve this question for you. I want you to pause this video and solve it ahead. Okay, and get the answer. Let's do it. Okay, done. So let's check the answer. What is the final value of differentiation? See, they have solved it the same way, same substitution, same format. Now you should be able to identify that. Okay, so the final answer is either this or this, anything, whichever suits you. 2 multiplied by 6 raised to x into log 6 to the base e, of course, and upon the whole upon 1 plus 6 raised to 2x. If you want to simplify to the next step, it is your choice. If you don't, then it's okay, no problem. You will still get marks. All right, let's go to the next question. Okay, the next question is, if y is equal to log of tan of, if y is equal to log of tan of pi by 4 plus x by 2, show that dy by dx minus sec x is equal to 0. So definitely we have to find dy by dx, and dy by dx has to be sec x. dy by dx has to be sec x because sec x minus sec x only will be 0. So we have to basically prove that dy by dx is sec x. How to prove dy by dx is sec x? We have to differentiate this. Okay, let's see how to differentiate. Good differentiation, yeah, good practice. So y is equal to log of tan of pi by 4 plus x by 2. Okay, therefore dy by dx, differentiating both sides with respect to x, we get. So the first thing is d by dx of log of tan of pi by 4 plus x by 2. So in the first step, we are going to treat this whole thing as x, log of x. Okay. Then we are going to proceed with the chain rule and write again d by dx of tan of pi by 4 plus x by 2. Then we are going to proceed and write multiplication multiplied by d by dx of just pi by 4 plus x by 2. And in the second step, we are going to treat this as x, the stuff which we don't touch. Correct? Now we can easily find the value of dy by dx. I think my students are quite smart, smarter than me, I feel at times. Uh, so I feel that you can definitely crack this. Do it. Okay, so pause the video and try it. Please try it. I want you to try it because this is now this I have made it very very easy for you. Okay, so I think that you should be able to crack it very easily and you should be able to make this sec x. Can you do it? Come on, please do it. Pause the video and solve it completely. Okay, let's check. So first we have log of tan of pi by 4 plus x by 2. So this tan of pi by 4 plus x by 2 will be treated as x. And what is the differentiation of log of x to the base e? Log of x to the base e is nothing but 1 by x. Right? Log of x to the base e is 1 by x, the simplest differentiation. So we get 1 by tan of pi by 4 plus x by 2. I will show you the answer. Multiplied by d by dx of tan of pi by 4 plus x by 2. So we'll treat that pi by 4 plus x by 2 highlighted term as x. So what is d by dx of tan x? Sec square x. So we get 1 upon tan of pi by 4 plus x by 2 as the first term multiplied by sec square of pi by 4 plus x by 2 as the second term multiplied by d by dx of pi by 4 plus d by dx of x by 2, which is 1 by 2. Right? And then we simplify it and we get sec x like this. They have converted tan in terms of cos and sine and cut this and simplified it further. They have used the formula 2 sine a plus b cos a plus b as sine of 2 sine a plus b sine 2. One second. Let me recollect this formula. This is 2 sine theta cos theta. Yes, this is 2 sine theta cos theta, which is sine 2 theta. 2 sine theta cos theta, which is sine 2 theta. That's why I thought that how did this become double? So this is that 2 sine theta cos theta formula, which is sine 2 theta, which is sine 90 plus theta, which is cos theta. So 1 upon cos theta is sec theta. Right? So easy question. Chalo, next one. This is also simple. Although it is hot, but not difficult. let's do this one. So we have y is equal to log of x to the base 10 plus log of 10 to the base x plus log of x to the base x plus log of 10 to the base 10. You have to find dy by dx. I think it is pretty simple. First, let's simplify uh, this itself, this expression itself, and then find the differentiation. We are not in a hurry to find differentiation. So y is equal to log of x to the base 10 plus log of 10 to the base x plus log of x to the base x, which is 1, plus log of 10 to the base 10, which is also 1. We know the rules of logarithms. Okay, so this will be y is equal to log of x to the base 10 plus, see, log of 10 to the base x can be written as 1 upon log of x to the base 10 plus 2, right? And then we take LCM. So what will be the LCM? Y is equal to log of x to the base 10 the whole square plus 1 upon log of x to the base 10. Okay, plus 2. Okay, so yes, this is what we have. And if we didn't take LCM, I think then also it could have been solvable because we have to differentiate it. So I feel that this step is little unnecessary. Yeah, this is quite simple. We can differentiate this. So dy by dx is equal to d by dx of log of x to the base 10 plus d by dx of log of x to the base 10 the whole raised to minus 1 plus d by dx of 2. Correct? Now, what is d by dx of log of x to the base 10? Remember, this is not log of x to the base e, because that would have been straight away 1 by e. But here you are going to get 1 by x multiplied by log of e to the base 10. That is the formula. Okay. Here you are going to apply chain rule. Okay. So first you are going to treat it as x raised to minus 1. Okay, x raised to minus 1. So we have minus 1 and we get this. We get minus 1 over here multiplied by 1 upon log of x to the base 10 the whole raised to 2. Yes, multiplied by d by dx of the inside thing, d by dx of log of x to the base 10, which we already know, which is 1 by x multiplied by log of e to the base 10. Okay, so this is the final jumble plus 0 because d by dx of 2 is 0, right? So what do we have here? We have log of e to the base 10 the whole upon x. Okay, so here I'm just going to open the bracket and I feel that this plus sign, when I open the bracket, this is definitely inside minus sign. So this plus sign does not exist over here. So I'm just going to put minus sign over here. And in the numerator, I'm going to get log of e to the base 10. And in the denominator, I'm going to get x multiplied by log of x to the base 10 the whole square. Log of x to the base 10 whole square. Log of x to the base 10 the whole square. Okay, great. Okay, we had to find dy by dx, and we are very near, but this doesn't seem to simplify so early. Okay, so how to simplify this? So we had 1 by x, we had log of e to the base 10, we had log of x to the base 10, the whole square in the denominator. Okay, I think why not take LCM and simplify this, yeah? Because I don't think this is a very convenient form to express the log of e to the. Oh, okay. So I think we can do one thing. We can bring everything in terms of log of something to the base e. Yeah, I think we can do that. So the only thing which is required is to bring this into log of something to the base e. We have log of x to the base 10. Okay. Okay, let's try. So see, the first term will become 1 upon x log of 10 to the base e. 1 upon x log 1 upon x log 10 to the base e minus 1 upon 1 upon x multiplied by log of 10 to the base e multiplied by log of x to the base 10 the whole square. Okay, so we just have to simplify this. Now then every log will become a natural log. That's what our idea should be, that every log should become a natural log. Okay, and how to do that one? Hmm. So we have log of x to the base 10. Let me check. ओके, तो इट्स वेरी क्लेवर यार, मैंने थोड़ा सोचा इसके ऊपर सोल्यूशन भी देखा, फिर जाके मेरी ट्यूबलाइट जली इसमें। x मल्टीप्लाइड बाय लॉग ऑफ 10 टू द बेस e। तो बेसिकली क्या है कि हम लोग पूरा आंसर को नेचुरल लॉग में लेके आ रहे हैं। तो यहाँ पे तो टू द बेस 10 है, उसको हटाएंगे कैसे? तो एक तरीका है, एक फॉर्मूला मुझे याद आ गया, x मल्टीप्लाइड बाय लॉग ऑफ 10 टू द बेस e मल्टीप्लाइड बाय log of x to the base e upon log of 10 to the base e the whole square। तो फॉर्मूला ऐसा है कि if we have log of m to the base n, we can write it as log of m to the base x upon log of n to the base x। मतलब इसको हम लोग ऐसे ट्रांसफॉर्म कर सकते हैं। तो ये वाला फॉर्मूला हमने यूज किया, प्लीज थोड़ा नोट कर लेना इसको। ओके, अब क्या होगा कि ये तो स्क्वायर में है, ये तो स्क्वायर में है, तो ये इसके साथ कट जाएगा। ये ये एक टर्म इसके साथ कट जाएगा, एक टर्म ऑलरेडी यहाँ पे रहेगा, ठीक है, नीचे रहेगा। तो इसको हम लोग सिंप्लीफाई कर देंगे, इसको हम लोग सिंप्लीफाई कर देंगे। 1 upon x log of 10 to the base e minus 1 upon x multiplied by log of x to the base e the whole square, वो तो स्क्वायर में ही रहेगा, the whole upon log of 10 to the base e, ये सीधा ऊपर चला जाएगा। so we have 1 upon x log of 10 to the base e minus log of 10 to the base e upon x log of x multiplied by log of x to the base e the whole square। ये तुम्हारा फाइनल आंसर है। ठीक है, इसको इधर ही छोड़ देना, कोई प्रॉब्लम नहीं है। तो सबको नेचुरल लॉग में हम लेके आए और ये थोड़ा सा एक टेक्निक यूज किया है यहाँ पे। सो दैट्स योर फाइनल डेरिवेटिव। ठीक है, समझ में आया? चलो नेक्स्ट क्वेश्चन पे आगे बढ़े। लेट्स डू दिस वन। We have reached the end, so just hold on. Okay, क्या है हमारे पास? e raised to x plus e raised to y is equal to e raised to x plus y. Prove that dy by dx is equal to जो भी यहाँ पे दिया है। अब एक तो है कि जो गिवन इक्वेशन है उसको सीधा ही डिफरेंशिएट कर दो या फिर उसको सिंप्लीफाई करके डिफरेंशिएट करो, लेकिन मुझे कोई इतना फर्क नहीं लग रहा है बिकॉज एनीवेज वी वुड गेट हाँ ई रेज टू एक्स को अलग करके ई रेज टू वाई को सॉरी अलग करके हम लोग डिफरेंशिएट कर सकते हैं, या ई रेज टू एक्स को अलग करके डिफरेंशिएट कर सकते हैं। मतलब इसको थोड़ा सिंप्लीफाई कर सकते हैं हम लोग ताकि इजीली हो जाए। लेट्स ट्राई ना। e raised to x plus e raised to y is equal to e raised to x plus y. So e raised to x plus e raised to y is equal to e raised to x into e raised to y. ठीक है, तो मैंने तुम्हें बताया कि इसको सिंप्लीफाई करो। e raised to x प्लस e raised to y the whole upon e raised to x is equal to e raised to y, ऐसे लिख सकते हैं। So e raised to x upon e raised to x plus e raised to y upon e raised to x is equal to e raised to y। ठीक है, तो ये कट के क्या हो जाएगा? 1। सो 1 is equal to e raised to y minus e raised to y upon e raised to x। ठीक है, यहाँ से कॉमन निकाल सकते हैं, तो 1 इज इक्वल टू ई रेज टू वाई कॉमन आ जाएगा। अंदर क्या बचेगा? अंदर बचेगा 1 माइनस 1 अपॉन ई रेज टू एक्स। ठीक है, मैं सिंप्लीफाई करने की कोशिश इसलिए कर रहा हूँ बिकॉज डिफरेंशिएशन बाद में इजी हो जाएगा। ये तो जो फॉर्मेट में दिया है उसमें डिफरेंशिएशन में भी तुम्हें काफी लंबे स्टेप्स लेने पड़ेंगे, सो उससे अच्छा है पहले ही सिंप्लीफाई करो। तो this will become, अब you want me to take LCM? I think it's better we take LCM, right? So it will be 1 is equal to e raised to y bracket e raised to x minus 1 the whole upon e raised to x, e raised to x minus 1 the whole upon e raised to x। ठीक है, तो it will become e raised to x the whole upon e raised to x the whole upon e raised to x minus 1 e raised to x minus 1, वो साइड चला गया, is equal to e raised to y। Now we can differentiate with respect to x if possible. Of course it is possible, there is nothing impossible, but on differentiation what you are going to get, that we don't know. Yeah, you should get this, so let's see what we get. Okay, so we have e raised to y is equal to e raised to x upon e raised to x minus 1. Differentiating both sides with respect to x. So d by dx of e raised to y is equal to d by dx of e raised to x the whole upon e raised to x minus 1. So ये हो जाएगा e raised to y dy by dx, and यहाँ पे you will apply your quotient rule. So e raised to x minus 1 multiplied by d by dx of e raised to x minus e raised to x, ब्रैकेट डाल देता हूँ, multiplied by d by dx of e raised to x minus 1। The whole upon e raised to x -1 द होल स्क्वायर। तो ये जो e रेस टू वाई ना, उसको यहाँ पे नीचे लेके आ जाओ पहले ही, तो dy बाई डी एक्स अलग हो जाएगा। ठीक है, तो यहाँ पे आ जाएगा dy बाई डी एक्स इज इक्वल टू, ये हो जाएगा e रेस टू एक्स, डी बाई डी एक्स ऑफ ई रेस टू एक्स इज ई रेस टू एक्स ब्रैकेट ई रेस टू एक्स माइनस वन। इसको ऐसे ही रखो, अभी पता नहीं ब्रैकेट खोलने पे क्या निकलेगा, क्या कॉमन है, कुछ है कि नहीं। ठीक है, तो यहाँ पे आ जाएगा ई रेस टू एक्स ब्रैकेट d by dx of e raised to x is e raised to x, and d by dx of 1 is 0, so minus 0. So यहाँ पे आएगा e raised to y ब्रैकेट e raised to x minus 1 the whole square। हो जाएगा सिंप्लीफाई, ये इजी। आई थिंक, मुझे लगता है कि उन्होंने जो मेथड की उससे ज्यादा इजी ये वाली मेथड मुझे लग रही है। आई डोंट नो। सो dy by dx is equal to, सो देखो यहाँ पे तो अपने पास क्या बचा, e रेस टू एक्स मल्टीप्लाइड बाई e रेस टू एक्स, मतलब e रेस टू एक्स द होल स्क्वायर। अगर e रेस टू एक्स द होल स्क्वायर सिर्फ है अपने पास और उसको मैं बाहर निकाल दूं, तो बाहर क्या बचेगा, e रेस टू एक्स। देखो यहाँ भी e रेस टू एक्स था और यहाँ पे e रेस टू एक्स मल्टीप्लाइड बाई e रेस टू एक्स। सपोज एक e रेस टू एक्स है, उसको मैंने बाहर निकाल दिया, तो अंदर क्या बचेगा मेरे पास, अंदर बचेगा e रेस टू एक्स माइनस वन, वो तो बचेगा ही, माइनस e रेस टू एक्स। समझा, e रेस टू एक्स माइनस वन, यहाँ पे सिर्फ e रेस टू एक्स बचा, द होल अपॉन e रेस टू y ब्रैकेट e रेस टू एक्स माइनस वन द होल स्क्वायर। सो dy बाई डी एक्स इज इक्वल टू, देखो e रेस टू एक्स माइनस ई रेस टू एक्स कट, सीधा माइनस वन बचेगा, सो ई रेस टू एक्स माइनस वन द होल अपॉन ई रेस टू वाई ब्रैकेट ई रेस टू एक्स माइनस वन द होल स्क्वायर। ठीक है, तो यहाँ पे ये कट जाएगा और डी वाई बाई डी एक्स विल गिव यू, ये स्क्वायर कट जाएगा, तो वन अपॉन ई रेस टू वाई ब्रैकेट ई रेस टू एक्स माइनस वन। अब तुम्हें प्रूव क्या करना है, कुछ चीज तो मुझे लग रहा है कि कुछ आया नहीं है कुछ चीज। हाँ ओके, लेट्स सी। हमको प्रूव करना था dy बाई डी एक्स इज इक्वल टू, डिनोमिनेटर में e रेस टू वाई ब्रैकेट e रेस टू एक्स माइनस वन पक्का है, न्यूमरेटर में मेरे पास सिर्फ वन है। ओ हो, न्यूमरेटर में सिर्फ वन है। हाँ, तो वन की वैल्यू है अपने पास, ये देखो ना, वन की वैल्यू, वन की वैल्यू डालते हैं ना, आएगा शायद न्यूमरेटर भी। आई एम नॉट श्योर बट स्टिल, आई एम नॉट श्योर, देखते हैं। तो बेसिकली मेरा सिर्फ वन अजीब है ना, वन नहीं होना चाहिए, बाकी डिनोमिनेटर ई रेस टू वाई ब्रैकेट ई रेस टू एक्स माइनस वन सही है। ठीक है, तो न्यूमरेटर में क्या होना चाहिए, ओके, तो वन की वैल्यू क्या है, सॉरी फॉर दैट, देखो वन इज इक्वल टू ई रेस टू वाई ब्रैकेट ई रेस टू एक्स माइनस वन, e raised to x minus 1 the whole upon e raised to x। ओहो, तो एक e raised to x ज्यादा आ रहा है, ऐसा कैसे ज्यादा आ रहा है, आई थिंक सही है, सही है, सही है, सही है, हो जाएगा, हो जाएगा, हो जाएगा। तो ये वन की वैल्यू है e raised to y upon e raised to x द ब्रैकेट e raised to x minus 1। ओ, कुछ तो गड़बड़ किया है मैंने यार, बिकॉज मुझे डिनोमिनेटर सही आ रहा है और डिनोमिनेटर और न्यूमरेटर में e रेस टू एक्स माइनस वन कॉमन आ रहा है मुझे, और यहाँ पे नेगेटिव भी है साइन, मुझे तो नेगेटिव आ नहीं रहा है। ओ, कुछ तो लोचा है यार, मैंने कहाँ पे प्रॉब्लम किया, लेट्स चेक। देखो e रेस टू एक्स प्लस e रेस टू वाई, लेट मी चेक, मैं पॉज करके चेक करके फिर तुमको बताता हूँ, मैं ढूंढ लेता हूँ पहले। ओके, आई थिंक मैंने एक मिस्टेक किया था और वो मुझे गलती मिल गई है। लेट मी शो यू मेरी सिली मिस्टेक क्या है। तुमको समझ में आया पता नहीं। सी ये ई रेस टू एक्स मल्टीप्लाइड बाय -1 है, ठीक है, तो ये हो जाएगा माइनस ई रेस टू एक्स, माइनस ऑफ ई रेस टू एक्स, ठीक है, अपॉन ई रेस टू वाई तो है ही, ठीक है, मल्टीप्लाइड बाय, यहां पे कुछ भी नहीं बचेगा, अब बचेगा 1 अपॉन ई रेस टू एक्स -1 द होल स्क्वेयर, ठीक है। तो हमें जो प्रूव करना है ना, उसके मोस्ट ऑफ सारी चीजें हमारे पास आ गई है। क्या क्या आ गया हमें प्रूव करना है उसमें? माइनस ऑफ ई रेस टू एक्स अपॉन ई रेस टू वाई आ गया, ठीक है, और डिनोमिनेटर में ई रेस टू एक्स -1 आ गया, लेकिन न्यूमरेटर में ई रेस टू वाई -1 नहीं आया। उसकी जगह पे जो डिनोमिनेटर है उसमें क्या आया है हमारे पास? ई रेस टू एक्स -1 द होल स्क्वेयर, एज यू कैन सी ओवर हियर, ठीक है। तो इसको थोड़ा और सिंप्लीफाई करके लिखेंगे, dy बाई डी एक्स इज इक्वल टू माइनस ऑफ ई रेस टू एक्स अपॉन ई रेस टू वाई, यहाँ पे ब्रैकेट, एक मिनट, इसको थोड़ा अच्छे से लिख सकते हैं। सो माइनस ऑफ ई रेस टू एक्स द होल अपॉन ई रेस टू वाई ब्रैकेट ई रेस टू एक्स -1, ठीक है, इतना तो आ गया। और साथ में क्या आया है? 1 अपॉन ई रेस टू एक्स -1 और एक आ गया है, क्योंकि स्क्वायर था ना तो मैंने ऐसे अलग से लिखा। अब जस्ट मुझे क्या करना है? ई रेस टू एक्स -1 की वैल्यू डाल देनी, 1 अपॉन ई रेस टू एक्स -1 की वैल्यू डालनी है। तो 1 अपॉन ई रेस टू एक्स -1 की वैल्यू क्या होगी? चलो, हमारे पास रिलेशन तो है, ये रहा। तो अगर मैं इसी रिलेशन को आगे सिंप्लीफाई करूं तो आई गेट 1 अपॉन ई रेस टू एक्स -1 इज इक्वल टू ई रेस टू वाई अपॉन ई रेस टू एक्स। क्या है उसकी वैल्यू? ई रेस टू वाई अपॉन ई रेस टू एक्स। चलो डालते हैं, ई रेस टू वाई अपॉन ई रेस टू एक्स डालेंगे तो ये तो कट जाएगा इसके साथ। हम्म तो हमारे पास -1 अपॉन ई रेस टू एक्स -1 बचेगा सिर्फ। तो क्या डाल सकते हैं इसकी वैल्यू? या 1 की जगह कुछ वैल्यू डालनी है, या फिर अच्छा, अगर 1 की जगह भी कुछ वैल्यू डालें, जैसे अगर हमने 1 की वैल्यू निकाली है, आ, देखो हमें न्यूमरेटर में ई रेस टू वाई -1 चाहिए, तो अगर हम लोग 1 की जगह वैल्यू डालते हैं, यहाँ पे 1 की जगह इफ वी पुट ई रेस टू वाई ब्रैकेट ई रेस टू एक्स -1, वो भी कट जाएगा, ओके। और क्या कर सकते हैं, इसको कैसे सिंप्लीफाई कर सकते हैं? क्योंकि हमारे पास ई रेस टू, अच्छा ठीक है, ई रेस टू एक्स की वैल्यू डाल देंगे हम लोग यहाँ पे, ई रेस टू एक्स की वैल्यू डाल के सिंप्लीफाई करेंगे ना ई रेस टू वाई के टर्म्स में, शायद फिर आ जाएगा। तो ई रेस टू एक्स की वैल्यू क्या है? हमने निकाली हुई थी ई रेस टू एक्स की वैल्यू, ई रेस टू एक्स की वैल्यू हमें यहाँ से मिल जाएगी डिनोमिनेटर में, जो ई रेस टू एक्स है यहाँ पे न्यूमरेटर में। तो ई रेस टू एक्स की वैल्यू क्या है? ई रेस टू एक्स इज इक्वल टू ई रेस टू वाई ब्रैकेट ई रेस टू एक्स -1। तो अगर मैं ई रेस टू एक्स की जगह पे ये वैल्यू डालता हूं तो क्या होगा? एक मिनट, ये वाली नहीं डालते, हम लोग सिंप्लीफाई करते हैं इसको। ओके, गिव मी सम स्पेस, मैं थोड़ा इसको इसको इरेज कर दूंगा। हम्म मैंने जो ई रेस टू वाई को सब्जेक्ट बनाया था ना फॉर्मूला का, अभी ई रेस टू एक्स को मैं सब्जेक्ट बनाता हूँ फॉर्मूला का, ठीक है। सो आई एम जस्ट गोइंग टू गेट 1 इज इक्वल टू ई रेस टू वाई। देखो यहाँ पे, एक मिनट, इफ आई राइट 1 अपॉन 1 माइनस 1 अपॉन ई रेस टू एक्स इज इक्वल टू ए रेस टू वाई, कोई प्रॉब्लम नहीं है, राइट। इसको सिंप्लीफाई करते हैं, 1 अपॉन ई रेस टू एक्स -1 अपॉन ई रेस टू एक्स इज इक्वल टू ई रेस टू वाई। ई रेस टू एक्स ऊपर चला जाएगा, ई रेस टू एक्स अपॉन ई रेस टू एक्स -1 इज इक्वल टू ई रेस टू वाई। हमको ई रेस टू एक्स को सब्जेक्ट बनाना है फॉर्मूला का, तो e रेज टू x इज इक्वल टू e रेज टू y ब्रैकेट e रेज टू x माइनस 1, ठीक है। सो e रेज टू x इज इक्वल टू e रेज टू y इंटू e रेज टू x माइनस e रेज टू y, ठीक है। यहां से e रेज टू x माइनस e रेज टू y इंटू e रेज टू x को इधर लाएंगे, माइनस e रेज टू y यहाँ पे रहेगा, e रेज टू x कॉमन आ जाएगा and will be left with 1 minus e raised to y is equal to minus e raised to y. So which is e raised to x is equal to minus e raised to y upon minus e raised to y upon 1 minus e raised to y, minus e raised to y upon 1 minus e raised to y. चलो डालते हैं e raised to x की जगह पे। Okay, so dy by dx is equal to minus of e raised to x upon e raised to y bracket e raised to x minus 1 multiplied by 1 upon ये जो e raised to x है उसकी जगह पे मैंने अभी जो वैल्यू बताई तुम्हें माइनस ऑफ e raised to y upon 1 minus e raised to y, माइनस ऑफ e raised to y upon 1 minus e raised to y minus 1। चलो इसको सिंप्लीफाई करते हैं। So dy by dx is equal to minus of e raised to x upon e raised to y bracket e raised to x minus 1 multiplied by यहाँ पे LCM लेने के बाद जो डिनोमिनेटर है वो ऊपर चला जाएगा एंड that will be 1 minus e raised to y जो ऊपर आ जाएगा। आई थिंक वही हमें चाहिए था, वही हमें चाहिए था, राइट? हमें चाहिए था e रेज टू y माइनस 1। ओके कोई बात नहीं, माइनस की साइन आ जाएगी शायद। अच्छा नीचे क्या बचेगा? नीचे बचेगा माइनस ऑफ e रेज टू y माइनस ब्रैकेट में 1 माइनस e रेज टू y, करेक्ट हो जाएगा। सो dy बाई डी एक्स इज इक्वल टू माइनस ऑफ e रेज टू x अपॉन e रेज टू y ब्रैकेट e रेज टू x माइनस 1 ब्रैकेट क्लोज, ठीक है, मल्टीप्लाइड बाय 1 माइनस e रेज टू y द होल अपॉन माइनस e रेज टू y माइनस 1 प्लस e रेज टू y। अच्छा ये तो कट जाएगा, ये माइनस 1 जो आया वो ऊपर मल्टीप्लाई हो जाएगा। सो dy बाई डी एक्स इज इक्वल टू माइनस ऑफ e रेज टू x ब्रैकेट e रेज टू y माइनस 1, राइट? ये माइनस ऊपर चला जाएगा, ये माइनस 1 का माइनस, ठीक है। तो इसकी पोजीशन चेंज हो जाएगी, साइंस चेंज हो जाएगी। तो बेसिकली अपॉन ई रेज टू वाई अपॉन ई रेज टू एक्स माइनस 1, यही हमें प्रूव करना था। हाँ तो थोड़ा लंबा हो गया, एंड में थोड़ा लंबा खिंच गया ये। इस पॉइंट के बाद शायद, इस पॉइंट के बाद 3 4 5 स्टेप्स शायद और बढ़ गए, बट या वी गॉट द आंसर ऑन सिंप्लीफिकेशन, ठीक है। तो ये एक क्वेश्चन था। अब जो लास्ट क्वेश्चन है, अच्छा इनका काफी इजी आ गया है बिकॉज उन्होंने डायरेक्ट डिफरेंशिएट किया था दोनों साइड एंड फिर dy बाई डी एक्स को कॉमन लेके उन्होंने आंसर निकाल लिया था। 4 स्टेप में आंसर आया है। अगेन अगर तुम्हें 4 स्टेप में आंसर आता है डायरेक्टली, गो फॉर इट, ठीक है, गो फॉर इट। तुम्हें जिस तरीके से समझ में आता है तुम उस तरीके से कर सकते हो, डोंट वरी अबाउट दैट। ओके नेक्स्ट क्या है? फाइंड द डेरिवेटिव ऑफ साइन ऑफ लॉग एक्स बाय चेन रूल विथ रिस्पेक्ट टू एक्स बाय चेन रूल एंड डेल्टा मेथड। चेन रूल तो अपने को पता है और इसमें कोई प्रॉब्लम नहीं होगा चेन रूल अप्लाई करने में। डेल्टा मेथड इज बेसिकली योर फर्स्ट प्रिंसिपल्स। तो एक तो ये क्वेश्चन नोट कर लो क्योंकि ये दोनों आपको करना है, चेन रूल से भी आपको करना है और डेल्टा मेथड से भी आपको करना है। डेल्टा मेथड लेट मी टेल यू थोड़ी लंबी होगी। डेल्टा मेथड मतलब फर्स्ट प्रिंसिपल्स वाला मेथड जो लिमिट यूज करके हम करते हैं। इट विल बी अ लॉन्ग मेथड, but yes, that's what they have asked, so you have to do it that. Okay, and if you want I can share the solution with you after you solve it. So yes, that brings us to the end of this part. अब कुछ शायद 2 टॉपिक और बचे हैं इस चैप्टर में, फिर एप्लीकेशन ऑफ डिफरेंशिएशन पे हम चले जाएं, एप्लीकेशन ऑफ डेरिवेटिव्स, ठीक है। सो आई विल सी यू इन द नेक्स्ट वीडियो, बाय बाय।